want to talk about recursion. If you go to Coding Interview Prep on the Free Code Camp website, you'll find an algorithm that asks you to find all the permutations of a string and then eliminate from that array all the strings that have repeating letters. In another video, I'd like to tackle this whole question, but I'm going to dedicate this video just to tackling the part of the solution that generates permutations. This is something that you're going to want to know on the job and especially for a technical interview. Technical interviews may or may not be a valid metric for how well you're going to do on the job, but unfortunately it's a moot point because employers love them. And one of the technical interview questions you're going to encounter is, how do you find permutations? If I give you a string, how do you find all the different arrangements of letters in that string? Here's the function that does it. I did not write this function. It is a tool created by someone else, but you can learn to use it. There are two things about this function that I want you to know before we dive into how it actually works. This function uses another function called swap. Swap is up here. All swap does is it swaps two items in an array. And for sake of clarity, I'm just going to make this A and I'm going to make this B, because I don't want you to get hung up on 1 and 2. I'm going to pass it two numbers, and those numbers are going to stand for indexes in an array. Those indexes could be 1 and 2, they could be 0 and 1, they could be 0 and 2. It doesn't matter. Whatever the index is, it's just going to swap those. So for example, if I pass it 0 and 2, it's going to swap 0, which is A, and 2, which is B, and the resulting array will just be BAA. The second thing I want you to know is that generate is a recursive function. It calls itself. A recursive function is a function that calls itself. Its name is generate, and down here inside of this loop, we're calling generate. Over here I have this box called generate. This represents a call to the function. But generate is a recursive function, so I have these other boxes down here that are identical except they're smaller. And I'm going to try to visualize for you how recursion works by putting boxes inside of boxes. This is a visual representation of a recursive function. Here's the function, it calls itself. This function calls itself again. This will happen to infinity if you don't write your recursive function properly. You have to build into your recursive function a way for it to stop. The way they did it here was they put it inside of a loop. So once the conditions of this loop are met, the recursive call will not be made, and this function will finish this section and it'll finish the function. This visual thing right here represents a stack. It's a call stack. A stack is actually a data structure in computer science. A stack is something that allows you to work only with the last item that was put on the stack. Once you stack this function call, you can no longer deal with this one until you finish this one. That's enough theory for now. Let's walk down through this function here and see if we can visualize what's happening when we use generate. We're going to pass this function called permalone a string, and the string is going to be AAB right here. On line 6, JavaScript is going to turn our string into an array, and that array will of course be AAB. By the time we get down to generate, here we've defined generate, but on line 43 is where we use it. The argument that we're passing in is the length of our array. Well, you can see that the length is 3. So the first time we use generate, int will be 3. Let me represent that here with the number 3. Walk down through the generate function, it's going to ask a question, does int equal 1? No, we just said it equals 3. So skip over this and go down here. Now we're inside of a loop where we're going to be calling generate. So let's keep some good notes here. We already said that int equals 3, but I at this point equals 0. Let's write that in. Get to line 34 and we are going to call our function inside of itself. But this time we're going to call it on int minus 1, which is of course 2 because int equals 3. Let's go back over here and let's add a function call to the stack. What is JavaScript doing? It sees that you've called generate, so it just goes right back up to line 23, and because you've passed int minus 1 as an argument, it's going to run line 23 with 2 in here. So let's represent that. Int equals 2, so therefore it does not equal 1. We're now back into a loop again. But we're not in this first call, we're in the second call. So I equals 0, and int equals 2. And guess what? We reach line 34 again. Except this time, we're calling it on 2 minus 1, which is 1. And JavaScript just steps right back up to 23. It's going to run generate with the argument 1. Does 1 equal 1? It sure does. Now we're going to begin affecting items outside of this function. This is where our work is getting done. This empty array that we defined up here called permutations is going to get something pushed to it. What are we going to push to it? We're going to push to it the present state of our array, and we're going to turn it back into a string. That's what this does. What is the present state of our array? We kept track of it up here. The present state of our array is AAB. So let's push AAB to permutations. AAB is turned back into a string. So that's what permutations looks like now. Now, because we called generate and passed 1 as an argument, guess what? That call to the function finishes right here. That call is done. So let's visualize that by taking this call off the stack. We're done with it. We are now back in this second call, which means where does JavaScript pick back up? It's just going to pick up with line 35. So we're going to run the swap function on the present state of our array. Again, I didn't write this. This is all complex stuff with lots of moving parts, and it's difficult to understand, but let's attempt to understand it. Int right now equals 2. We noted that. So 2 mod 2 equals 0. 0 is a falsy value. That means this ternary operator here, it's going to select the item on the right side of the colon, which is I. I, at this point in time, equals 0. First thing we're going to pass to swap is 0. The second thing we're going to pass is int minus 1, which is 2 minus 1, which is 1. So if you go back up here to swap, we're passing 0 and 1. Well, what does that do to our array? Let's actually do it manually. All we're going to do is swap index 0 and index 1, which visually doesn't change anything here, but in terms of permutations, it counts. Behind the scenes, we've switched A and A. AAB is the present state of our array. In function call 2, we now finish that iteration and we go back up to the loop, and I now equals 1. Let's represent that here with 1, 2. I equals 1, N equals 2. And guess what? We reach line 34 again, so we have to add something to the stack. We're calling generate with the argument 1 again, so it's going to go up here, int equals 1, so we're going to push something to our permutations array. What are we going to push? The present state of the array. What is the present state of the array? The present state of the array is AAB. Let's turn AAB into a string and push it. We've now finished this call to generate. Where will our program pick back up? With swap. Now swap does an interesting thing here. What is int? It's 2. 2 mod 2 is 0, which is falsy. So we're going to choose I. I is 1 at this point. 2 minus 1 is 1. So we're literally just swapping index 1 with index 1, which does nothing either visually or in terms of a permutation. It's just a step that's needed because the genius who wrote this algorithm knew that it needed to be done. I didn't remove this. We need to remove this off the stack. But guess what? We have now finished this loop here, which means we've also finished. We can take this call off the stack. Now where are we? We are back out into the original call. We are at iteration 0, and we have 2 more to go. So where is this code going to pick up? We just went down the rabbit hole several times on generate. Now we're coming back up to the most shallow level, or the first call. It's going to pick up right here at swap again. What does int equal? Int equals 3. 3 mod 2 is 1. That's a truthy value, so that the first index will be 0. But 3 minus 1 is 2. We're going to pass swap the arguments 0 and 2. Well, what does that do to our array? Present state of our array is AAB. We're swapping 0 with 2. So that's literally just swapping A and B. Now the present state of our array is BAA. Go to the next iteration, which I will represent here. 1, 3. Now we're back in this loop, and we have to call generate again. You can see that I've moved this function call back onto the stack. JavaScript's going to go right back up to line 23. It's going to run generate on int minus 1, which is still 2, which means that I equals 0 and int equals 2, as I've represented here. And we reach line 34 again, which means we have to put another call on the stack. This call is 2 minus 1, which is 1. So JavaScript's going to walk right back up to 23. Call generate with 1 as an argument. 1 does equal 1, so guess what we're going to do? We're going to push something to the permutations array. We're going to push the present state of our array to the permutations array. What is the present state of our array? The present state of our array is BAA. Turn BAA into a string and we're going to push it, you can see that this array of permutations is starting to take shape. Because this was generate with 1, it finished right here, so guess what? We get to take it off the stack. It's going to pick back up with line 35. We're going to do some swapping. What are we going to swap? 2 mod 2 is 0, which is falsy, so we're going to pick the second option here, which is 0. Present state of I, 2 minus 1 is 1, so we're going to swap 0 and 1, which is B and A. So now, the state of the array is ABA. We're going to finish this iteration, and we're going to go to the next one, which I will represent here. We are now on 1, 2. We have to call generate again. Generate 2 minus 1 is 1. Walk back up to line 23. Generate on 1. Does 1 equal 1? Yes, it does. Push the present state of the array to permutations. What is the present state of the array? ABA, ABA. Pick back up with swap. What does swap do? 2 mod 2 is 0. A falsy value. Pick the second of the two options here, which is now 1. As you can see over here, 2 minus 1 is 1. So we're literally doing that sort of useless step, but it has to be done for this algorithm machine to work properly. We're just switching B with B, which does nothing visually or in terms of permutations, but it does allow us to go to the next step. Now we have satisfied, oh, see, I forgot to take this off. We finished generate when called with argument 1, and now we've satisfied this loop here, which means we're done with this second call as well. Now where are we? We are back out into the first call. We've removed everything off the stack except the original call, but we're only on the second iteration. So now we're going to 2. So I now equals 2, int still equals 3, but guess what? We have to call generate again. We're calling generate with 3 minus 1, which is 2. So step right back up, generate 2. 2 does not equal 1. We're back into a loop. I equals 0, int equals 2, and I'll represent that here. And we're calling generate again. As I'm pulling this up here, let me remind you that recursive functions are not necessarily efficient. In order to get all the permutations of a simple 3-letter string, we're going to have to run generate 10 times. If you add just one more letter, we run generate many, many more times. We're now running generate with the argument 1. Go up to line 23. Generate 1. Does 1 equal 1? Yes, it does. So let's push the present state of our array to permutations, ABA. We finish this function. Let's take it off the stack. Let's do a swap. 2 mod 2 is 0. So let's take second argument here, which is the present state of I, which is 0. Int equals 2. 2 minus 1 is 1. We're going to swap 0 and 1, which will bring it back to BAA. Finish these steps here. Go to the second iteration of our second function call, which is 1, 2, and then we have to bring generate back on the stack. Calling generate on 2 minus 1, which is 1, int equals 1, so let's push the present state of our array to permutations. Present state of our array is BAA. We have now finished this function call. We do a swap, which is, as you've seen before, on this iteration, it's just going to swap A with A, which does nothing visually or in terms of permutations. But we now have satisfied the conditions of this loop inside the second function call. And look at this, we've also satisfied the conditions of this loop for our original function call. So guess what? We're done. This recursive function has finally finished. We called generate 10 times just to get all the permutations of a 3-item string. And you can see that it's worked because these are all the permutations. Here's what I hope you take away. First, this is an algorithm that I did not write. I don't think I could ever write this, honestly. If you're struggling with recursion, understand that you're not alone. It's a mind bender because it's hard to keep track of everything that's happening. What I attempted to do was break it down and show you how it works. The other takeaway is I wanted to visualize how recursion works. Picture you're hovering above this stack where generate keeps calling itself. A stack is a computer science data object that allows you to deal only with the last item you put on. The last item that goes on the stack is the first item that must go off the stack before anything else can be done. In order to get this recursive function to stop calling itself so that it doesn't go on to infinity or generate a Stack Overflow error, you have to have a way for the function to stop. And the way this guy did it is that he put the recursive call inside of a loop. Once that loop is satisfied, the recursive call is not made. The last takeaway is it's good just to have this written down somewhere so that if you ever need to generate permutations of a string, you could just use this. I hope this helps. Recursion is difficult to understand, but the best advice is to watch this video or videos like it, really slow down and focus on what recursion does, and with patience and time, you'll get it. Please like this video and share it, and I'll see you next time.